Welcome back. So we looked at declarative sentences, right? But we also see that they are not enough to give language meaning. More often than not, we find that in English, for example, a sentence has got more than one statement, right? A sentence usually is a combination of multiple statements, right? And that is enabled by the usage of operators, right? We use statements like however, and, or, but, right? So these allow us to join different statements. So for propositional logic, right, since it is a language of its own, we also have propositional logic operators, right? So the logic operators that we have got 5. The first 4 are conjunction, disjunction, implication, and if and only if. Right. So conjunction, right? The English synonym for conjunction is, we've got and, but. The synonyms for disjunction are or, sometimes it can be written as either or. Then implication is if P, then Q, right? And then if and only if is aptly named. So if and only if. So it's if and only if. So it stands for if and only if. Right. Now, let's look at how these operators behave. So a conjunction, right, takes 2 inputs, or all these 4 operators, they take 2 inputs. We can say they are binary operators. Right. Now, these binary operators, what do? The conjunction takes in 2 inputs, right? Its output will only be true, right? The output will only be true if both inputs are true. Right? Meaning, if I say John and Mary are married, John and Mary, let me use a different name. John and Jane are married. Right. If John and Jane are married, this statement as a whole is true if John is married and Jane is married. So that is the only time when this statement is true. So if John is married but Jane is not married, then the statement John and married becomes false. John is not married, Jane is married, the statement becomes false. Both are not married, the statement becomes false. All right. So in logic, we have got interpretations that differ from English. Right. So just think about it, what the statement John and Jane means, are married means. Does it mean John is married to Jane? Are they married to separate people? What would be your interpretation of this statement? Right. So you realize that any scenario where John is a marriage contract and Jane is a married contract is valid. Whether they're married to themselves, whether they're all married to someone, if it's a polygamous relationship or whatever, any scenario that results in both of them having a marriage certificate is valid. Right. So let's look at disjunction. Disjunction is an either or statement. So if we take the very same statement and we now have John or Jane is married. So this simplifies to the following. Right. The OR statement says at least one of these two has to be true for an OR statement to be true. So at least one means one or more. Here we've got one being true, therefore the statement has to be true, though we have the bonus extra one for being true. Here John is married is true, Mary is not true, therefore is true. If John is not married, Jane is married, therefore true. Now it is only false when both inputs are false. That is the disjunction operator. Then we look at the implication. It says if John is married, then Jane is married. If John is married, then Jane is married. All right, let's look it up. So, when is this statement as a whole true? At what point would you consider it to be false? So let's evaluate. John is married is our P. Q is Jane is married. So let's see. Let's say John is married, and we then find out that Jane is also married. This resolves to true, because if John is married, then Jane is married. If we then find out that John is married, but Mary is not married, then we have a contradiction. This statement is not true, because it says, given that John is married, Jane should be married. Right. But now we're finding that though John is married, Jane is not married. Therefore, we have got a false interpretation. Then we also have false going to true. Right. If John is not married, so we were very strict to say, given that John is married, Jane should be married as well. How about we find out that John is not married? Right? If we find out John is not married, then our basis for an argument falls away. Right? Our basis for an argument falls away. Our basis for argument was that whenever John is married, Jane has to be married as well. Now, we have John not being married, so our basis for argument falls away. So for these two, we don't have a basis for an argument. So you see that it resolves to true always. Right, we can further sweeten it by saying the following statement. There was nothing said about John not being married. So whether Jane is married or not, the statement becomes true in its entirety, because we have got no basis to judge Jane being married or not. All right. So that is if and only if. So if P, then Q. Moving on to if and only if, right? If and only if is a biconditional, right? So this is a conditional. This is a biconditional. What does this mean? So this is derived from two operators that we have already looked at. So we have got, this can be written as P implies Q and Q implies P. It is the conjunction of these two. So what you essentially do is you then say, what is P implies Q? P implies Q over here will be true, false, true, true. True implies true, true implies false is false, false implies true, false implies false. Then you have Q implies P, true implies true, that's also true. False implies true, that's also true. True implies false, that is false. False implies false, that is true. And now I want to find the conjunction of these two. True and true, that's true. False and true, that's false. True and false, that's false. True and true, that's true. So you see that this column is similar to this column over here. So a biconditional is a derived operator. If and only if it's a derived operator, it comes from the combining or from combining implication and conjunction. All right. Now, looking at implication further, whenever you're given P implies Q, you can interpret it as if P then Q, that was one. The other implication is Q if P. So take note here, it's Q, which is this side, if P, which is that side. And it can also be interpreted as P only if Q. P only if Q. That's another interpretation you can have. Right. So be careful when they use if and when they use only if. All right. So another interpretation is whenever you see the word unless. So unless is got in, it has got an implication inside it. So I can say John is married unless Jane is married. What does this mean? John is married unless Jane is married. So unless says this is true on the condition that this is not true. John is married on the condition that Jane is not married. So it becomes not Q implies P. So P unless Q, we have got not Q if John is not married. If Jane is not married, then John is married. If Jane is not married, then John is. And this is also an equivalence to say P implies Q is the same as not P or Q. When you draw the truth table, you can observe the equivalence there. Lastly, now, we want to look at the distribution of, I think before this, we need to look at the last operator, which is negation. So negation is a unary operator, meaning it accepts one input. Right? So say we have got P, we want the negation of P. It gives us true, it gives us false. The negation of true is false, negation of false is true. So it takes one input and it negates the truth value of that input. So this leads us to variations of conjunction. You can negate a conjunction, right? So if P and Q means both P and Q, then this means not both P and Q. So P and Q is true, false, false, false. The negation of that is going to be false, true, true, true. Not both. As long as both are not true, it should be true. Then we also have distributivity. So we have got a conjunction of B or C. Right, so we call this the disjunction normal form. So it's disjunction normal form or DNA. So disjunction normal form says you distribute this end into the brackets and then you have a disjunction there. So it is a disjunction of conjunctions. So it's a disjunction of conjunctions. A and B or C, you're going to have A and B, or A and the closely related cousin is conjunction normal form, which is a conjunction of disjunctions. So what do we have? We've got a conjunction of disjunctions inside the bracket. So A or B and C, you are going to have A or B and A or C. Right, so we can negate the disjunction of two operators, so or two statements, not P or Q. So not P or Q. P or Q means at least one is true. The negation of at least one, because at least one means one or more. So it means less than one are true. So in our case, none are true. So this means none are true. So the negation of this would be false, false, false. It's only true when both of them are. Let's take a pause there. Let's continue in the next.